Alright, extending on from our families of polynomial video, just taking a quick look at finding the turning point in this form up here. Right, so to be able to do that, we need to be able to, by now we should, I guess, be able to recognize from this equation that our turning point would be at 5, 4. And we're going to take a quick step back and have a look at why that's the case. So we need to get our calculator up to understand that. I've got him here now. If I go ahead and graph as I've done here, graph the equation y equals x squared, we've got a turning point at 0, 0 here. Alright, what happens is, regardless of what the power is, it's x squared here. If we uncheck that and check y2 and graph him now, I've got x cubed minus 4. Alright, so this is a minus 4 outside of the immediate x cubed. If I go ahead and graph that, what we see is that when the negative 4 is outside the x cubed, that shifts the turning point down 4 units. Right, if I was to graph x to the power of 3 without having that guy there, I need to select that box. You can see that x3 is right at the origin, x to the power of 3 is right at the origin, x to the power of 3 minus 4 has been shifted down 4 units. That's what happens when you have a minus 4 outside of the brackets. If it's inside the brackets, so if I select x to the power of 4, it's going to get shifted 1 unit to the left. So the turning point here, as you can see down the bottom of that calculator screen, is at -1, 0, or thereabouts. I can't get it on there exactly. So when it's inside the brackets, it shifts to the left and to the right. So if we then go back to this question, so essentially what we're doing in this area here is we're setting these brackets equal to 0 and then solving that. So on both sides we're going to add 5, and so our x coordinate of our turning point is going to be equal to 5, and that's why we can directly just read it off, and there it is there. This guy we have to do a similar thing to, alright, but instead of saying, intuitively you might think that the turning point would be at -6, -7, but that's not quite right. What we need to do, as we did over here, was set the brackets equal to 0. So this is wrong. So we have 2x plus 6 equal to 0. The power doesn't matter, it was 4 there, it's 3 here, we ignore that. We then have to solve for x. Right, and so that ends up giving us 2x equal to -6, and then as we divide by 2, we're going to have x be equal to -3. So that's the x coordinate of our turning point. So that means our turning point would be -3, -7. So let's be really, really careful in this, that when we see turning point questions, we need to make sure that the whole bracket has got a coefficient of the x term. Just one last thing, this isn't a coefficient of the x term because it's sitting outside of the bracket, so we don't need to ignore that. What that guy does is either make it thinner or wider, not shift the position along the x or y axes. Alright, good stuff.